For more information, please visit SGMAK Associates website.
Hi, here is another audio file on quadratic equation, part 3. So I have, I think, about 10 problems. Let me go over them. And like I said, if you, any of you need any help, you can always get in touch with us. The email address is there, and also you know how to get in touch through YouTube. Okay, first problem. If the quadratic equations, there are two of them here, ax squared plus 2cx plus b equals 0 and ax squared plus 2bx plus c equals 0, have a common root. So if quadratic equations have two roots, and now you've got two quadratic equations and they have a common root, so it's common for both. You designate them as alpha. So if they have a common root, what's the value of a plus 4b plus 4c? So let's say the common root be alpha, then it alpha satisfies both the quadratic equation, and then we use that, and to solve, since c minus b not equals 0, alpha comes out to be 1/2. So if you put that back into the first quadratic equation, then well, both will give the same answer. So a over 4 plus c plus b equals 0, or a plus 4c plus 4b equals 0. We'll get the same answer if you put alpha 1/2 as the root of the second equation. Okay, moving on. The second problem, the real values of a for which the quadratic equation 2x squared minus a cubed plus 8a minus 1 times x plus a squared minus 4a equals 0. Find the real values for a. Now if a quadratic equation have equal, in this case, roots of opposite sign, that means the product of the roots will be negative. But in this case, what you have to do, we got to first form it in a standard, convert into a standard form with the coefficient of x squared as 1. So we divide both sides by 2. The equation is x squared minus 1/2 of a cubed plus 8a minus 1 multiplied by x plus 1/2 of a squared minus 4a equals 0. The product of the roots is 1/2 of a squared minus 4a. Since roots are of opposite sign, then this quantity must be negative, and this is only valid if a is between 0 and 4. The product will be negative if only a is between 0 and 4. Okay, so that's the range for a. The quadratic equation b squared plus c squared multiplied by x squared minus 2 times a plus b times cx plus c squared plus a squared equals 0. So you can always map it in terms of ax squared plus bx plus c. Now this equation has equal roots, so the discriminant must be equal to 0. So if we set up as a discriminant, then we get the expression a times b equals c squared. So which is so you can write it as a over c equals b over c over b. A over c equals c over b, or if you write abc, acb, then c over a is b over c. That gives you ab equals c squared. So a, c, b are in geometric progression. In a geometric series, consecutive terms, if you take two consecutive terms, they have the same ratio. Take the ratio of two consecutive terms, they remain the same. Let's move on. If alpha and beta are roots of the equation ax squared plus 3x plus 2 equals 0, and a is less than 0, then alpha plus beta is minus 3 over a, and alpha times beta is 2 over a. That's standard form. And since alpha beta the equation, Then individually they satisfy a alpha squared plus 3 alpha plus 2 equals 0, a beta squared plus 3 beta plus 2 equals 0. Then you are given an expression alpha squared over beta plus beta squared over alpha. That becomes, if you algebraically, alpha cube plus beta cube over alpha time divided by alpha times beta. And then if you go through the algebra and then substitute the value for alpha plus beta is minus 3 over a, and alpha times beta is 2 over a, we get a value minus 3 times 9 minus 6a over 2a squared, which is less than 0, which is negative. A is less than 0, so a squared is negative. A is less than 0, so 9 minus 6a is positive. So whole expression is negative. So alpha squared over beta plus beta squared alpha is less than 0. Okay, moving on. Example, a not equals 0, b not equals 0. So let alpha and beta, the roots of the equation x squared plus ax plus b equals 0. Then we have the relationship alpha plus beta is minus a, is in a standard form, and alpha times beta is b. Now find the roots, equation with the roots 1 over alpha and 1 over beta. So the equation will be x squared minus sum of the roots times x plus product of the roots, and that gives you, as you can see, by simplifying, the equation becomes x squared plus ax over b plus 1 over b equals 0, or bx squared plus ax plus 1 equals 0. Okay, so we're simply using, if I'm given the roots, the equation is x squared minus sum of the roots times x plus product of the roots equals 0. Okay, continuing on this example, what if the roots are minus alpha minus beta? The same logic, x squared minus alpha minus beta x, then the product of the roots, so that gives you x squared plus alpha plus beta x plus alpha beta. We know the value of alpha plus beta and alpha beta, so that comes out to be x squared minus ax plus b equals 0. Now similar logic with roots alpha over beta and beta over alpha. So now the sum of the roots is alpha over beta plus beta over alpha, and the product is 1. So through simplification, the equation comes out to be bx squared plus 2b minus a squared times x plus b equals 0. Okay, using the same principle again and again. All right. Next problem. If A, B, C are in geometric progression, then the equations x squared plus 2bx plus c equals 0 and dx squared plus 2cx plus f equals 0. If these two have a common root, given that A, B, and C are in geometric progression, then there's a relationship between d over A, e over B, and f over C. They are in arithmetic progression. Okay, so using the first condition, first, A, B, C are in GP, geometric progression, so B squared equal A times C. So you can write the first equation, x squared plus 2bx plus c equals 0 as square root of ax plus square root of c whole thing squared. So roots are, so they are identical roots, minus square root of c over a, identical roots. Now, x squared 2bx plus c and dx squared plus 2cx plus f have a common root. So now you put minus c over a in the second equation. So you get d times c over a minus 2c times square root of c over a plus f equals 0. Or through simplification, you get d over a plus f over c equals 2 times c over b. So when three terms in AP, the middle term twice the middle term is the summation of the first and third term. So in this case, we can show that D over A, C over B, and F over C, they are in arithmetic progression. Problem. If alpha, beta are the roots of the quadratic equation 6x squared minus 6x plus 1, then once you convert into standard form, x squared minus x plus 1/6 equals 0. Sum of the roots is 1 and product is 1 over 6. Now it says find the value of 1/2 of a plus b alpha plus c alpha squared plus d alpha cube plus 1/2 of a plus b beta plus c beta squared plus d beta cube, not beta squared. So if we algebraically manipulate, it's 1/2 of 2a plus b times alpha plus beta, c times alpha squared plus beta squared, d times alpha cube plus beta cube. Now alpha plus beta is 1, we put that. Alpha squared plus beta squared is alpha plus beta whole square minus 2 alpha beta, and alpha cube plus beta cube is alpha plus beta raised to the power 3 minus 3 times alpha beta into alpha plus beta. So now we substitute the values we know and we get an expression a plus b over 2 plus c over 3 plus d over 4. So that's the value of this expression in terms of alpha and beta given here. Okay, so it's just an application of the very basic principles. Some of the roots in a standard form, some of the roots is coefficient minus of coefficient of a, product is the constant term. Okay, so next problem. This is, if you look at this expression, this is kind of infinite recurring series. So it can be best written as x as square root of 2 plus x. If you square both sides, you get a quadratic equation x squared minus x minus 2 equals 0. The roots are minus 1 and 2. Since these are all positive numbers, so value should be x equal to 2. Minus 1 is not admissible. Example, if a, b and c are real numbers, a greater than 0, find the minimum value of the expression x squared plus bx plus c. It's an interesting problem. A lot of examples can be molded in this form. So x squared plus bx plus c, what you're trying to do here, we're trying to break it into two parts. One part we set up as a perfect square and then whatever is remaining. So that comes out to be a times x plus b over 2a squared whole square plus 4ac minus b squared over 4a. You can just follow the algebra. First line is a times x squared plus b over x plus c over a. We are writing that as 2 times 2b over a times x plus, then we take b squared over 4a squared, then we subtract minus b squared over 4a squared plus c over a. So first three terms becomes a times, that becomes a perfect square, x plus b over 2a. And then the next term remaining is 4ac minus b squared over 4a squared. So when you multiply both sides by a, the first term is a perfect square, the second term is a 4ac minus b squared over 4a. So if you look at this expression, the minimum value we get when the perfect square, minimum value of the perfect square is 0. That happens when x is minus b over 2a, and the minimum value is 4ac minus b squared over 4a. A lot of examples can be solved using this principle or using this approach. Here you are solving symbolically a, b, and c. With the numerical values for a, b, and c, same approach can be taken. Okay? All right. Hi. We are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.